Hi, everyone. Sorry we couldn't join you in person this year, but thanks to Nick, Sasi, and the whole Flower team for inviting us to give this talk virtually. As was mentioned in the intro, I'm Mohammad Manzari. I'm an R&D manager at Deloitte, and I'm joined by Minh, who's from our R&D team as a senior engineer. We focus on privacy-enhancing technologies, research and development, and our group has been working on federated learning for the last 3 years. Most recently, we've been interested in the intersection of generative AI and federated computing. So this talk will start with an overview of federated RAG systems, cover some privacy and security considerations. Then Min's going to discuss the concept of confidential federated RAG, and then we'll wrap up with some time for questions and answers. Just a quick disclaimer about Deloitte before we jump in. We've included some references and hyperlinks at the end if you're interested in learning more. Okay, so many of you have heard about federated RAG, but I wanted to just start with our motivation for working on these federated RAG systems, as well as some of the techniques that might be involved when implementing federated retrieval augmented generation. So in traditional RAG, we assume that all the data that we'll need is centralized somewhere, and it's readily accessible by the large language model that we're using. Typically, there's also a single embedding model that's chosen to vectorize the data. But when you're working with a network of data providers, this is likely not going to be the case. In this scenario, you might need to incorporate a few different flavors of federated computing. So for example, you might want to train a federated embedding model across the network's corpora without directly sharing any of the data between the participants. Or you might want to expose a federated data catalog to users in discovering and selecting data products that they can use in answering their queries. Finally, you might also need to implement a federated retrieval mechanism that both performs the local similarity search at each data provider site, but also is then able to retrieve that context and aggregate it at a central orchestrator. So you might be asking, okay, these are the different ways that I could federate the system, but how does that actually look like in practice? The basic puzzle pieces are actually pretty straightforward. You can see here that if we were to implement this in kind of like a chat type interface, a user would submit their query to that interface that's hosted on an orchestrator. And then that query would be routed by the orchestrator to external data providers. And each data provider, once they receive the query, would run a local similarity search, retrieve the relevant information from their vector stores as seen in step 3 with the retrieval engine. And then in step 4, the retrieved data is sent to the orchestrator where it's re-ranked and synthesized into a final prompt. And then that final prompt is sent to an LLM in the inference step, generates a response, and the final response is sent back to the chat interface and displayed to the user. There's obviously many different variations on this type of process and this architectures, and there's some really exciting and interesting research being done across the federated learning community to really kind of push forward what's possible with these systems. Okay, so despite the exciting possibilities that FedRAG systems present for data-driven collaborations, there's some important security and privacy risks that we should consider. First and foremost, the possibility of an untrusted orchestrator. So given the position and the importance of the orchestrator in routing queries and also aggregating responses, any privileged user or, for example, an administrator on the orchestrator might be able to view, reuse, or tamper with context from data providers. And you might also have both malicious prompting and inadvertent data disclosure that might occur as end users might attempt to reconstruct data sets, or the large language model might accidentally leak sensitive information to the end user. To talk a little bit about how some of these security and privacy risks can be addressed using privacy enhancing technologies, I'm going to hand it over to Minh.
All right. Thanks, Mohammed. So today I'm just going to go through a little bit more on the detail of the confidential computing part, just for the sake of time and not repeat like the whole steps. But the 3 main things here that we need to focus on is really the data providers, the aggregator, and the LLM model. So in the perspective of like untrusted orchestrator, this new proposed confidential federated system actually reduced the attack surface by pretty much protecting your aggregation part and your LLM model. The only way to really interact with the code that is running is actually through some kind of client or parent server that is able to connect to the isolated hardware. And due to that, you actually am able to control the data that's going in, but also what is executed, but only that part can be executed, nothing else can be interfered with. Once it goes into that process of confidential computing and actually start processing the environment. And I'm going to walk through a little bit of what I mean by that. So essentially, a user submitted some kind of query, it goes in the router, then it gets sent to a data provider. Now, within the data providers, each of them can control what they want to give out, but also they're able to filter out things such as maybe even throw in PII scrubbing, or even such things as maybe, let's say, I don't want to send these information to this particular person because they don't have access or certain level of security level, so then they cannot get these information. So basically, within each data provider, they can control the level of data that's being sent out, and they can also sanitize it. So then these things can all be done locally. Once those things are done, once you send it back to the server, you actually, unlike the original approach where you send it back to the orchestrator, where it then control, like the whole process and everything is kind of shared together. This time around, the data provider encrypted the data, so then it becomes encrypted while in transit. Once it gets sent back to orchestrator, it actually doesn't go back to the central orchestrator. It goes into a confidential computing environment for aggregation. Only there can it be decrypted and then aggregated and do the re-ranking and so on before being sent to the LLM model, which is also in a confidential computing. So as you can see, like the whole process itself is actually encrypted and only decrypted within a confidential computing. Now, the final way, like the final addition to this step is that to just, I guess, additional layer of security and privacy, instead of just relying on the process to kind of scrub out the PII where the data provider controls that, we also implement additional layer of PI scrubbing at the LLM model itself. So just to recap, once the data goes in data provider, they implement their own kind of sanitizations, PI scrubbing, encrypt the data, send it back to the orchestrator where it's then being processed in an aggregator within the confidential computing environment. Once that is done, it gets sent to the LLM model where it then go through another layer of PI scrubbing and then processed by the LLM model and then decrypted before sending it back to the user interface. Okay, yeah, so you can go to the next slide. Yeah, so as I kind of briefly went through the confidential FedRAG pipeline, even though there are many more layers of security versus the original approach, there are a few things that we're still kind of researching in. And these are the 4 topics that we want to look at or we're currently looking at right now. So for example, number 1, new context aggregation approach. Obviously, there's many ways of kind of aggregating your results. And so we're constantly kind of digging through a few of those things. But some of the things I actually really want to highlight is actually benchmarking various performance in federated learning embedding models. There are so many different ways of kind of handling that, because I think something might be interesting if we can have some kind of shared embedding model, or even have like a orchestrator that can actually handle various different embedding models within data provider, because you can't expect all data providers to have the same embedding models, right? And then the third point is having a multimodal federated RAG system. That's one of my personal favorite future research area, as I'm more of a computer vision guy originally. So I think it's always kind of neat to implement that into a federated RAG system. And lastly, number 4 is analyzing privacy and utility trade-off. What I noticed is that throughout the process of like moving things into confidential computing, if not for the restriction of, let's say, maybe hardware restriction of GPU versus CPU, but even if GPU is enabled, you still have to go through multiple layer of processing. And I think through those multiple layer processing, there will be some kind of utility trade-off, right? Is it really scalable? Is the processing speed and the performance worth the trade-off? And like maybe for X amount of security or privacy, you can give up X amount, performance, right? So I think that's a trade-off that I'm actually kind of really curious on. We do benchmark some of these things. We have records of them, and so that's something we definitely want to explore continuously. So lastly, here is just this is a reference to the paper that we worked with NVIDIA, and here's a link to it, and also. The Flower team actually implemented a FedRAG example in the link below, and which I actually played with. It worked very well, so good job on that.